Hi, students. So in this video, we're going to talk about some useful, what I call bridges. They're basically equivalent conversion factors that allow us to switch between the metric system and the imperial system, our system. So again, we take measurements. There's different types of measurements. A really common one is length. So we might take a ruler and measure out the length of something. And we can see that in a meter stick, right, there's uh, 10 decimeters in 1 meter, or 100 centimeters in a meter, or 1,000 millimeters. So this 100 is showing that there's 100 centimeters. So between 10 centimeters, there's actually 1 decimeter. So really, this is 10 decimeters. Now, what if I wanted to convert not within the metric system, but between the systems? Well, I can take a ruler, and sometimes your rulers, you can just flip them over, and one side will be centimeters and the other side will be inches. But if I measure something by their length, I can use either the units of inches or the unit of centimeters. And if I look at the unit of centimeters, I'll see that 1 inch is 2.54 centimeters. So how can I use this? I can use this as a conversion factor, what I call a bridge. Now, there are other bridges for length. 1 mile is, roughly 1.609 kilometers. That's why a 5K is basically 3 miles. But we're not going to be running miles in a lab setting, right? We're not going to be measuring out kilometers. So what's a little more useful? Well, this bridge right here. I can use 1 inch as 2.54 centimeters. And that allows me to go from our system into the metric. Now, what about volume? Well, if we look at volume, we can't forget that volume is length times width times height, okay? And what they're showing for this volume is we have 1 liter. And the 1 liter is 10 centimeter by 10 centimeter by 10 centimeter. Really, this 1 liter, if 1 decimeter is 10 centimeters. We just saw that with the ruler, right? This 1 liter is 1 decimeter cubed. And why is that? 1 decimeter times 1 decimeter times 1 decimeter, right? 1 times 1 times 1 is still 1, but the unit decimeter cubed gives me 1 decimeter cubed. Now, if we look in terms of centimeters, right, it'd be a little bit different. 1 liter would be equivalent to 1,000 centimeters cubed, right? And why is that? Well, 10 centimeter by 10 centimeter by 10 centimeter is equal to the number 10 cubed and centimeter cubed, right? Because 10 times 10 times 10 is 10 cubed. Or we'll just say 1,000 centimeters. So 1 liter is 1,000 centimeters cubed. So that's a really good way of looking at things in terms of when I have to take the unit to a power. So like for volume, I have to cube it. I don't just cube the unit. I'm not saying that the 1 liter is 1 centimeter cubed. It's 1,000 centimeters cubed. And why is that? I have to cube the number. So if I take a smaller portion, if I just take one of these little cubes, right, because there's 1,000 of these centimeter cubes in this, if I just take one of them and it's 1 centimeter by 1 centimeter by 1 centimeter, that 1 centimeter cubed is 1 milliliter. And that makes sense. And that's why we see this conversion that 1,000 centimeter cubed is 1,000 milliliters, and that's from our metric prefixes. Mill means 1,000. So milli means 1,000. There's 1,000 milliliters in 1 liter. If we also look, what I wanted to show people is what's used all the time is centimeter cubed is 1 milliliter. And you may have heard this in, shows, or if you work in the hospital, if they say, give me 1 cc, a cc stands for cubic centimeter, centimeter cubed. And 1 cc is basically 1 milliliter. So if someone says, I need 10 cc's, I need 10 milliliters, is basically what they're saying. But again, this discussion is to talk about, not do we just change within the metric system, right? So we're changing volume, which is, could be cubic units of centimeters, right? So there's 1,000 centimeters cubed in 1 liter, or 1 centimeter cubed in 1 milliliter, or 1 decimeter cubed in 1 liter. But we might need to change it within the system. So if we look, again, in our system, we measure quarts. And 1 quart is 946 milliliters. It's not 1 liter. And that's why if you look at a gallon, which is 4 quarts, it's typically shy of 4 liters. It's like 3.79, right? So we need a bridge between our system, quarts and gallons, to go into the metric system, milliliters and liters. So the base unit is liters in the metric system. We're going to use 1 liter as 1.06 quarts, and that makes it a little easier, right? So 1 liter is 1.06 quarts. And that makes sense because 1 quart, if we only had 1 quart, it's going to be less than 1 liter. And if it's less than 1 liter, what do we mean? 946 milliliters, which we could say is 1 quart is 0.946 liters, because I'm just taking milli and moving the unit over from milli, 1, 2, 3, because there's 1,000 milliliters in a liter. What about mass measurements? Well, when I measure mass, I put it on a scale and I read all the digits on the scale. So when I'm actually doing a digital measurement, I just use all the numbers as sig figs. And I see, I have a bunch of non-zero digits, and this 0 in the center is captive, so it counts. So in this particular measurement, I have 5 sig figs total, right? So there's 23.089 grams. Grams are the metric system, right? Well, what are we going to do? We're going to switch it from grams to pounds. Now, a lot of people might say, well, why not kilograms? Well, 1 kilogram is basically 2.2 pounds. We don't measure those types of quantities. So again, I'm trying to pick units or bridges that are useful for the lab. So what's that? In 1 pound, there's 453.6 grams. If you round to 454, there might be some slight round off error, but it'll get you to where you need to go. So I'm picking this as a bridge for you to know. And again, I want you to memorize these 3 bridges. So for mass, it was the 454 grams per pound. If we were to do length, it was 1 inch equals the 2.54 centimeters. And as we said earlier, there's in 1 liter, there's 1.057, or you could even say 1.06 quarts for volume. Those are the bridges I think are most useful for you to remember when you're solving those problems. Those are the bridges that, if I was to memorize any, Those would be the ones I'd memorize. Now, we did talk about temperature earlier, so I don't want to totally negate temperature. And here in the States, we use Fahrenheit. Everywhere else, they use degrees Celsius, and in science, they use the absolute temperature scale. So what I want people to realize is, 0 degrees Celsius is a really common temperature because that's where water freezes, right? That's actually 32 Fahrenheit. So here in the States, if it's less than 32 degrees, we know that it might snow or have sleet or hail, right? Now, if I was to boil water at 100 degrees Celsius, that is not 100 degrees Fahrenheit. So your hot tub that's at, 101.3 or whatever, that is Fahrenheit, okay? So 100 degrees Celsius is 212 Fahrenheit. That is a big difference. So how can we use these scales to figure out the differences in temperatures? Unlike the other measurements that I just discussed with mass, volume, and length, we're going to basically be using a formula method. So the formulas is Fahrenheit is equal to 1.8 degrees Celsius plus 32. So why plus 32? Well, this is almost like a linear function, right? Y equals mx plus b. B is my y-intercept, right? So when the x is 0, right? So when Celsius is 0, I'm at 32 degrees Fahrenheit. Now, if I go up, to 100 degrees Celsius, right? There's a difference in Fahrenheit from 32 to 212 of 180. So what did I do to that 100 degrees Celsius? I multiplied it by the slope, right? And this is a positive slope. So it's a consistent increase rate function of 1.8. So the formula to convert Fahrenheit, and we'll do calculations, don't worry, but the formula is Fahrenheit equals 1.8 degrees Celsius plus 32. Back in the old days, we used to always use fractions. So we would say Fahrenheit equals 9/5 times degrees Celsius plus 32, because 9/5 is 1.8. They kind of stay away from it, but I'd recommend getting comfortable with fractions again. You're going to be using them in this class. So that's how that's derived. And then for Kelvin, which is the absolute temperature scale, basically what you do is you take 0, right? And you add the 273.15. You just scale everything 273.15. So what's the difference between 100 and 373? 273.15. 0, 2. So it's pretty much the same rate of change, unlike Fahrenheit, which the rate of change was 1.8. The rate of change is the same, but we just have a different y-intercept. We have a different starting point. So for Celsius, we start at 0 degrees Celsius. On the Kelvin scale, that's 273. It's not absolute 0. And that's why scientists use Kelvin, because it's considered the absolute temperature scale. So I hope that helps. Again, there's more videos and more practice, and I'll see you guys soon. If you have any questions, put them on the discussion board, leave them in the comments, or you can email me. Thanks.